Okay, so let's talk about the SearchKDtree algorithm on how to search a range in a KD tree. So let's call the algorithm SearchKDtree. It gets two things. One is V, which is the root of the tree. It is a recursive algorithm, so it will change with time. And R is the range in which we look for the solution. So search KD tree, this is the algorithm, searching for a range which points in the tree are in a specific range. And let's start with a simple example so we can understand how it works. So here I have some points and let's build from it a KD tree. So it will be understandable. So let's do like maybe this. Okay, so let's build a KD tree. This is the median, and then I have this is the median here. Let's do it here. We have this one L1, L2, L3, and let's go to this side. We have this one. Let's take this, and here we have only this one. Let's call names to the points: P1, P2, P3, P4, P5. Now let's look at this one. Okay, now let's build a tree here. So this is L1, to the left there is L2, right? To the right there is L3, and to the left of L2 there is L4, and to the right there is P2, and to the left of L4 there is P1, and here we have L3, and to the left of L3 there is P5, and to the what about P3? This is to the right of L4, P3, and what we've got left, this is P4, this is to the right. Okay, so this is the KD tree. We have it the tree, we have it. Okay, now finding the region. Let's just make a random region and try to understand how we can get the point from this region. So let's make a region. Let's decide that this is the region. Okay, so which points are in the region? You can see them right over here. This one, that one, and this one. And we need to find that regions using the KD tree idea. So what we are doing, we are going to the L1. This is the V root, and we check, does the root is contained in the region? Does all the, now this is the root, so the subtree is all the points. Does this area is contained in the range R, which is this one? The answer is no, but another question is, does it intersect? The answer is yes. So we are going to the left and right. We are checking to the left. To the left we have this area, which is right over here, and we ask, does this area is contained in R? The answer is no. Does it intersect R? The answer is yes. If the answer is yes, so we are going next. So now we went to L1, then we said intersect, so we continue. We went left to L2, we said again intersect. We'll go to the right to L3, we'll again say intersect because it just intersect the region. So again it intersects. Okay, and we continue. To the left I have the L2. Yes, to okay. In the L2, if I go right, it again intersects. If I go right, it intersects, so I need to go right. So if I look at this now, at this area, this is to the right of L2. All the area with points is contained, so we will report this point. So we will report on P2 because it is a leaf, so we check if it is in the R. Okay, and to the left, we have this one, which is not in that area, and that one which does in. So when we are going to the left of L2, which is to below, we are going to L4. Now L4, we are looking at P1, which is this one. It's a leaf, so we check if it's in R. It's not in R. And we are going to the right to P3, which is in R. So we got again to a L4, and then P1 and P3. Now P3 is in R, P1 is not. Now we are going to the right of P3. To the right we have all this area. Again, this area intersects, but it is not contained in R. Now we are going to L3. We are going up. We see the leaf. We check, does the leaf is in R? The answer is yes, so we will report this. And we're going to the left. We have P5, and that's it. Now P5 is not in, is a leaf, and it's not in R, so we won't tell it. So this is how we finish this idea. Now let's write the algorithm, so maybe it will be more clear. So let's write the SearchKDtree. We get a V, we get the R, and let's write the algorithm. So let's write again. This is, we start with the root. It will change because it's recursive. This is the range we are looking for. And just for another thing to look for, let's say I change the range now, and the range is just this. Okay, this is the range. What I wanted to show, that now when I will be on L1 and I will go to the right, I will see that it doesn't intersect, so I won't continue with the right side. So this helps me in pruning part of the tree. Okay, so we'll see this idea. So we start this algorithm with going to the maybe the end when we are getting to a leaf. When we get to a leaf, we will ask if the leaf is inside the range R. If it does, we will report it. So we will check if the leaf, and if it does, then let's say report, but report if is part of R. Okay. Now if it's not a leaf, if it's not a leaf, you will ask if the left child of our V is, let's say, contained. Let's say contained. Let's say it's like this, and intersects will be presented as this. Okay, intersects, just for more convenient writing. So if L3 is totally contained in R, if it is totally contained in R, so we want to report it, because if it's totally contained, so we want to report all the subtree, then report subtree of the left child of it, okay. Now else if left child is only intersects R, namely it's not totally contained, so we need to look forward in the subtree of the left and continue looking. So we will do a recursive step, and we will do search. We will call again the function, but now instead of v, we will send the left child. LC is left child of v, and the same range. Okay, so this is what we are doing going left. We will do the same thing going to the right. So if now instead of left, we are doing the same for the right, right child of v is fully contained in R, then we will report again the subtree, report subtree, which is a function that we need to do, I don't know, any function that report the subtree of our right child of v. Again, just for it to be clear, RCV is right child of the node v. Okay, so now if the right child of v is only intersects R, then if it only intersects, we need to continue searching. So let's search KDtree, again recursive calling of our function, but now with the right child of v with the same range of R. And you can see here how I work throughout the algorithm. I start with the root, I check if it is a leaf, I check if I get to a leaf. If not, I check if it is contained, or the area, or the region to the right and region to the left. I check if this is contained and this region contained. If it's not contained, if it's not contained and not intersect, I will not continue with it. If it is totally contained, so I will say, let's say that this is totally contained in R, so I'll just report it if it's totally contained. If it's only intersect, so I'll just continue searching in this direction. If it's not intersecting and not contained, so just prune it. This is the idea. For example, if I have another range that is like this one, so my right side is totally contained, so I will just, if it happens, so I'll just report all the subtree. If the range is like only like this, so my right side is only intersects, so I'll continue looking by recursive calling of my function with the right child. And if again the range is not in that side, so the right side is not contained and not intersect, so I won't look to the right side and I will prune it. And of course I will go to the left and do the same. Check if it is contained, check if it intersects, or check if nothing is, and prune it, and by the results I will continue. This is the idea of the SearchKDtree. Thank you very much. If there are any mistakes or correction, please tell me. And that is it. Thank you very much.